Assalamualaikum, my name is Nur Shahira binti Zakaria and today I will present about Module 3 which is Spatial Analysis. The objective for Module 3 are: first, to understand spatial analysis tool; second, to create buffer and overlay of spatial data; third, to merge two or more feature classes into a single dataset. And now, let's go for the method. And now let's start for our method for Module 3. For the first step is buffering in RMap. Create a new RMap project and add the deriv SHP data layer and drag it to the table of content. After that, left click on the right up toolbar to activate the tools menu. Then click the analysis tool and click proximity and click buffer. The display window allows us to create a buffer layer. Set the input layer to deriv SHP. Specify the output feature's location and name. Enter the linear unit as 300 and set the units to meters. Set the resource type to all and then click OK. When the buffering process is finished, it should display the buffer data layer. Then we will redo this buffer, but this time, leave the default dissolve type to none. The second step is overlay in RMap. First, open our toolbar and then click Analysis tool and then click Overlay and then click Erase. Specify input features as a derived buffer 300. Specify the erase feature as a deriv SHP. Set the output destination in the output feature class and then click OK to apply the buffer. Once you have erased the link from the link buffer layer, the final step is to overlay the two buffer layer. Select up toolbar and then click Analysis tool and then click Overlay and then click Union. Then specify the input layers, District Kelantan SHP and deriv buffer 300 SHP. Then specify the output layer, deriv district union and then press OK. Examine the union layer and open attribute table for this layer. Select the polygon that meet both the within the root buffer and then within the leaks buffer criteria. Next, to determine the size experience, highest water and retention, overlay the river SHP District Kelantan SHP. Double click on Intersect tool in Analysis tool. Select deriv SHP District Content SHP for the input features and enter final SHP for the output feature class. And that is all for spatial analysis. And now let's start with the practical practices for this module. The first question is, discuss how the result differ between deserve all and deserve none in buffering and when will be this important. So first of all, what is buffering? So buffering is an important tool for determining the area covered with a specific location, and optional dissolve can be performed to rename overlapping buffer. So what is dissolve all and what is dissolve none? So dissolve all are all buffer are dissolved together into a single feature by removing any overlap. It can measure the distance between two-dimensional Cartesian plane. It has also a simple feature output. Next is dissolve none. So an individual buffer for each feature is maintained because of overlap and known as default. It is separate and has individual shapefile. It also has detailed graphic output, more detailed than this of all. Second question is, screen capture each overlay analysis done and explain the overlay feature. So the overlay analysis that we did are erase, union, and intersect. So for erase, it creates a feature class by overlaying the input feature with the erase feature. It will clear out the selected portion and a new shape class will be shown. An example, removing real feature from a map. Next is union. Union compute a geometric union of the input feature, combine every overlapping feature and make it as one. When combining state area, all of the states can be seen in the map. However, it can still be differentiated one by one. Next is the intersect. Intersect compute a geometric intersection of the input feature. The output feature class will be written by using overlap feature in all layers of feature classes. And now the third question is, how many records does final SHP have? So, the record for final SHP was 343 records. And the last question is, highlight all special analysis performed in this practical and relates the function of each analysis with real application in environmental context. So, the two things that we did for space analysis was buffering and overlay. So, we all know buffering is an important tool. It creates a buffer zone that is set in area within a specific distance. It has the purpose of protecting environment, residential area, commercial zone from accident or natural disaster. So, how do we take this buffering into the environmental context? So, as you can see, there's an article written by Ahmad Shibun in 2021. So, this article talks about a case study that was done by Shibun Ahmad. He talked about how the biodiversity is declining in sustainable livelihood and human well-being. So this buffer zone that was obtained by buffer can help conservation these areas to be intact. So this buffer can help the biodiversity, and next is overlay. So overlay, a method for determining the relationship between two polygon features that shares the common region. As we all know, before this, the three things in overlay are erase, union, and intersect. So as you can see, this article mapping risk areas of tuberculosis using knowledge-driven GIS model in Shah Alam, Malaysia, 2017. Even though it says 2017, this idea started in 2015 when WHO stated that Malaysia has the worst case of tuberculosis. So, therefore, overlay come in handy. So having this type of overlay, we can see the location that is really concentrated with factories that can harm the air pollution. If you don't know, tuberculosis can, one of the factors is air pollution, especially ambient pollution. So factories can release the gas dust, making some people have tuberculosis. In conclusion, after doing this module, we were able to understand spatial analysis tool, able to create buffer and overlay of spatial data, and also able to merge two or more feature classes into a single dataset. All things considered, all of the objectives were achieved. So that's all for module 3, and thank you so much for watching.